Let's solve Unit 1 Discrete Structures and Optimization questions. Let G of V, E be an undirected graph with L edges. Then the sum of degree of all vertices is equal to. We know there is a theorem called handshaking theorem. So let's take a graph G. Let this be an undirected graph with m number of edges. So V is a set of vertices and capital E is a set of edges. The count of edges is given by m. The sum of degree of all vertices will be equal to twice the number of edges, that is mentioned as 2 into m. Here the representation of the count of edges is L. So how many edges will it be equal to? It will be equal to 2 into L count of edges. Option number 1, 2L will be the right answer. So what is a degree of a vertex? The degree of a vertex in an undirected graph is the number of edges incident with it, except that a loop at a vertex contributes twice to the degree of that vertex. Let's take two vertices V1 and V2. Now there is an edge between these two vertices. Number of edges incident with a vertex means how many edges are involving V1. That will be the number of edges incident with it. If it is a directed graph, there is something called in degree and out degree. How many are going from a particular vertex, how many edges are coming towards a particular vertex, that constitutes in degree and out degree. So here it is undirected graph. So whatever edges involve a particular vertex, that will be the number of edges incident with that particular vertex. So we'll just see examples now. Let's take the following graph. Just count the number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then what should be the sum of degree of all vertices? It should be 2 into the number of edges count 9, which is equal to 18. Now we will manually check the degree of every vertex and then sum them up together to check whether we are getting 18. So what is the degree of A? 1, 2 edges are incident to it. So the degree of A is 2. What about degree of B? 1, 2, 3, 4 edges are there, so they have given 4. What about degree of C? 1, 2, 3, 4. So C is also having 4. What about D? Only 1. So we have the count of 1. What about E? 1, 2, 3. So E has 3. What about F? 1, 2, 3, 4. So F is also given 4. What about G? There is no edge connected to G, so G has a degree of 0. Now we have to count the degree of all vertices. A it is 2, B it is 4, C it is 4, D it is 1, E it is 3, F it is 4, G it is 0. Just count 2 plus 4, 6 plus 4, 10, 10 plus 1, 11, 11 plus 3, it's 14, 14 plus 4 is 18. So this is how they are calculating it using 2 into L. Now let's take another graph with loop. How many number of edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10th edge and this is 11th edge. The count of edges is actually 11 here. What about the sum of degree of all vertices? It should give 22. Let's check whether we are getting 22. Just remember, the loop at a vertex contributes twice to the degree of the vertex. So now we will calculate for A. Degree of A is 1, 2, 3, 4. Degree of B is given as 6. 1, 2, 3, 4, and we have to count the loop as twice to the degree. So this loop is taken to be 2. Already we have 4. 2 plus 4 will give you 6. So count the loop as 2. The remaining edges will be 4 and all together you will have B is equal to 6 as degree. What about C? 1. What about D? 1, 2, 3, 4, 5. What about E? 1, 2, 3, 4, 5, 6. So E is also having 6. Just count A plus B plus C plus D plus E. 10, 11, 16 plus 6 is 22. So this is how we'll be working out. Even when they give some graph and ask you to find the number of degree of vertices or the sum of degree of all vertices, I think now you will be able to compute it. That's why I included a graph without loop and with loop. While counting edges, this loop is just one edge. But when you count for the degree, you have to remember it contributes twice to the degree of the vertex. Next question. 40 software professionals were interviewed for a job. 25 knew Python, 20 knew Java and 7 knew neither language. How many knew both the languages? Out of 40 software professionals, they have told 7 don't know any of the languages. You have to exclude these 7 people. So the number of software professionals who knew at least one language can be computed by subtracting 7 from 40. 40 minus 7 will give you 33. Now from this 33, we know 25 knew Python, 20 knew Java, and we have to find how many of them know both the languages. So let's see it in the form of Venn diagram. Python is what we have mentioned as P, so the count is 25. This is actually with respect to the complete P. Similarly, if we take J, it is completely 20, the Java language. And 7 people are not involved in both Python and Java. Now the question is, how many people know both the languages? It means you have to find the intersection point of Python and Java as per this Venn diagram. Since we are using intersection operation denotion here, we know P union J is equal to 33. This 33 is a count where a particular professional can know just Python, can know just Java, or they can know both Python and Java. That possibility is given by this union operation. We have the principle of inclusion-exclusion formula here. A union B is equal to A plus B minus A intersection B. Here instead of A we are going with Python and instead of B we are going with Java. So why have they presented this particular symbol? It means you have to take the count and not the set completely. Now let's apply this here. P union J is equal to P plus J minus P intersection J. What is the cardinality of P? It is 25. What about the cardinality of J? It is 20. Now let's take this to be X. So this is minus X. And what about P union J? We know there are 33 professionals who know at least one of the languages. So this is equal to 33. So 25 plus 20 will give 45 minus X. X is equal to 45 minus 33, X is equal to 12. So the number of people who knew both Python and Java will be equal to 12. From this you can understand P intersection J is 12. So how many of them know only Python? It is 25 minus 12 which is equal to 13. How many of them know only Java? It is 20 minus 12 which is equal to 8. So this particular part that I have shaded will be contributing to 8 and this will be contributing to 13. Only when you add 13 and this 12 you will end up with 25, and only when you add 8 and this 12 you will end up with 20. If you are getting confused with this diagram, you can just forget about this and go with the formula alone. Since we don't have any of the options with 12, this question is a drop question as per the official answer key, and so we are not marking any of the options here. The correct answer will be 12. Next question. Let P be it is hot day and Q be the temperature is 48 degrees Celsius. Write in simple sentences the meaning of negation of P and negation of Q. If P is going to be it is hot day, what is negation of P? It will be it is not a hot day. If Q is going to be the temperature is 48 degrees Celsius, what is not Q? The temperature is not 48 degrees Celsius. We have to search for these two statements now. It is hot day is just P. Temperature is 48 degrees is just Q. We know this conjunction symbol is for and disjunction symbol is for or. So they have given or. Or means this symbol, but they are asking for negation of P and negation of Q. So one is not the answer. What about 2? It is cold day. When you say it is not a hot day, Definitely it is a cold day, so it may apply. What about the second one? Temperature is 48 degrees is still Q. So this is like negation of P and Q are involved, and since R is there, we are using R symbol here. This is also not equating to the question expression, we are ruling out. What about the third one? It is neither a hot day nor the temperature is 48 degrees Celsius. When will you use neither nor? When we say neither nor, it is like not a particular expression and not another particular expression. So negation is involved in both the places. At the same time, they are connected by and expression. Now just substitute neither a hot day is negation of P nor temperature is 48 degrees Celsius is negation of Q, and since they have used neither nor, we are giving and symbol here. So this is actually equal to the expression that is given in the question. Option number 3 will be the right answer. What about it is not a hot day? You are just going to negate P alone. So this is also not equal to the question. Next question. Let L of x comma y be the statement x loves y, where the domain for both x and y consists of all people in the world. Use quantifiers to express joy is loved by everyone. Here they have mentioned about x and y consists of all people, and here they have mentioned something as everyone. Both the terms are actually same. When we say it's all people, it includes everyone, everybody, all the people in the world. Anything can be synonymous to it. Joy is loved by everyone. When you put it in other way, you can say everyone loves joy. So both the statements are equal. Now we'll translate the expressions in the options. We know this symbol is denoting for all, or we can say even everyone. And of course we know this is there exist, or we can say it is someone. Now the first symbol is this one. So we have to start with everyone. How do we translate this actually? We say L of x comma y. So x is the first person, y is the second person, and loves will be the word. If they say L of x comma joy, it is x loves joy. What is x actually? It is all the people in the world. So we are using the word everyone instead of all people. So we can say everyone loves joy. So this is x and this is joy. This is exactly matching the statement that we have seen here. So everyone loves joy will be the right answer here. Option number 1 will be equating to joy is loved by everyone. So sometimes the statement is given in other way, but you have to interpret the direct meaning and then find the right option. Now we will also translate the other expressions. We have used for all y. So this is also everyone here. But here joy is sitting first and y is sitting next, which means joy loves everyone. But the question is, joy is actually loved by everybody. It means everyone is loving joy. So this is not matching with the question statement. What about the third one? We are involving y as well as x. This is actually existential quantifier and this is universal quantifier. When we use existential quantifier, it goes to someone instead of everyone. So when you have these symbols, this will denote someone. When you have this symbol or this symbol, it will denote everyone. Now we have x comma y. X loves y. So here it is everyone and y is given in the form of existential quantifier. So y is taken to be someone. So how will we translate the statement? There is someone whom everyone loves, or we can bluntly translate as everyone loves someone. Anyhow you can take it, and that is not equating to the question statement. So 3 is also ruled out. Now what about the fourth one? They have given negation of joy comma x. So joy is there, x is there, loves is there. When they say negation, it means joy does not love. And what about existential quantifier here? Instead of everyone, we have to substitute someone here. Joy does not love someone. This is the exact statement. In a proper way, we can say there is someone whom joy does not love. But here they have told joy is loved by everyone. So we are ruling out 4. So this is how you have to interpret all the options. Next question, translate this expression in English. Consider domain as a real number for both the variables. What are the variables here? X and Y. What is universal quantifier X? It is for all values of X or for every value of X, we can say. What about existential quantifier of Y? There exists a value Y, or for some value Y we can say. Using that, now we will try to translate every English statement to a particular mathematical expression, and we'll check which expression is equating to the question expression. For all real numbers X, so we know we have to use for all X. There exists a real number Y. We have to use existential quantifier such that X is less than Y. Now the expression should be X is less than Y. We have got this expression. Just check with the question expression. It is perfectly matching. So we can mark option 1 to be the right answer. Now we will also translate the other statements. For every real number Y. So this time it is for Y. This is for option 1. This is for option 2. There exists a real number X. So this is existential quantifier X. X is less than Y. Is this matching to the question expression? No. So we are ruling out this. What about the third one? For some real number X. So this is also existential quantifier. There exists a real number Y. This is also existential quantifier. X is less than Y. So this is also not the answer. What about the fourth one? For each and every real number X and Y, which says X and Y. For each and every is what we use for universal quantifier. X is less than Y is as usual represented as this way. So this is also not the right answer. So whenever you get such questions, make sure the other options are not right. Next question, out of the following steps in the proper sequence for simplifying a Boolean function using a K-map, they have asked for the steps. We'll take an example of 3 variables A, B and C. So how do we actually draw a 3 variable map? We'll just take a map like this. Then we will divide this as 1 variable and 2 variable. 1, 2, 3, 4. Draw the K-map for the given Boolean function. This will be the first step. Any option that starts other than B can be ruled out. After drawing the map, what we will do is we will start filling the values. This is 0, 0, 0, 1, 1, 1, 1, 0. So we have 0 and 1 here. This is 0, this is 1, this is 3, this is 2, this is 4, 5, 7 and 6. What are we actually doing here? We are transferring the truth table values to the K-map. So this will be the second step. B followed by D. We have only in one option, so rule out even 3. What is the next step we have to do? Based on a particular Boolean function, we have to check which places have 1. Based on that one, we have to group those ones together. Identify and group the largest possible cluster of ones is the next step, which is A. What about the final one? Write the simplified Boolean expression from the grouped clusters. This will be the last step. So if you group this way or this way, whichever value you find not changing, that value will be presented in the simplified expression. Option number 1, BDAC will be the right answer. It will be the proper sequence for simplifying a Boolean expression using K-map. Next question, a coin is tossed successively 3 times. Find the probability, event, sample space of getting exactly 1 head or 2 heads where n is the number of occurrence. When we toss a coin, what are the possibilities that we have? We can either have a head or a tail. The sample space of the experiment is the set of possible outcomes. What about event? An event is a subset of the sample space. When you take the sample space for one toss, it is just head and tail. But when you take sample space for 2 toss, for first head you may have head and tail for the second toss. For the first tail you may have head and tail in the second toss. All the 4 possibilities will be taken as sample space. But here they have given it is successively tossed for 3 times. So you have to consider 3 toss together. If S is a finite non-empty sample space of equally likely outcomes and E is an event that is a subset of S, then the probability of that particular event is given by N of E divided by N of S. So N is given as the number of occurrence. So N of E divided by N of S is what we term it as probability of the event. So what is the event mentioned here? The event here is we are getting exactly one head or two heads. So let's find the sample space first. We have toss 1, toss 2 and toss 3. So first we are taking head from the toss 1. So forget toss 1 now, get into toss 2. Here also you are getting head. In toss 3, what are the possible outcomes? Whenever you go for a toss, you either get a head or a tail. So toss 3 will have head for the first time and tail for the second time, or tail for the first time or head for the second time. There are two possibilities. So we are mentioning these two possibilities for head in toss 2, and if you take the tail in toss 2, you have two possibilities, head and tail. So for head you are having two possibilities, for tail you are having two possibilities between toss 2 and toss 3. For which toss we are computing toss 2 and toss 3? For the head part of toss 1 we are computing this. So when we have head in toss 1, there are four possibilities that are available in toss 2 and toss 3. If you are used to the truth table formats of three variables, you can compare this to 0 and 1. Now for the tail part of toss 1, we have the same four combinations. So let's take head first, then head and tail combination. Then for the tail we have head and tail combination. So for head we have 2, for tail we have 2. Now all these are applicable for the tail part. Now the sample space is 1, 2, 3, 4, 5, 6, 7, 8. So N of S is equal to 8 here. What about the event? Get exactly one head or two heads. So where do we have two heads? 1, 2, 3. We have 3 two heads, and they have also told about one head. So this is 4, this is 5 and this is 6. So there are 3 two heads and 3 one head. Overall the number of occurrences of event will be equal to 6. They have asked the probability, the event and the sample space. N of S is equal to 8, but here N of E is equal to 6. So we can take only this one and not this option. Now we have to find the probability. Probability is equal to N of E divided by N of S. So 6 divided by 8. When you cancel them, you can bring it to 3 divided by 4. So P of E is equal to 3 by 4. This is also right. We can rule out D. Option number 2, B and C only will be the right answer. So they have given the event occurrence and the sample space count in two options, and they have given the probability values in two options. So when they have asked the probability and event and sample space together, you can never have this combination of A, B, C and D. Rule out option 1. Once you find N of E is equal to 6, you can rule out A also. Similarly, they have asked for three values P, E and S. But when you take the fourth option, both are talking only about the probability. So just by reading the question, 1 and 4 can be ruled out. When you find N of E is not equal to 4, you can rule out even option 3. Next question. Consider the following relations on set 1, 2, 3, 4. Which of the following relations are reflexive? A relation R on a set A is called reflexive if A belongs to R for every element A that belongs to A. So applying this to the set that is given in the question, if this is going to be A, this can be taken as 1, 1, this can be taken as 2, 2, this can be taken as 3, 3 and this can be taken as 4, 4. So you have to find all these 4 in the given options. If you have them, we can conclude the relation is reflexive. Let's check for A. We have 1, 1, we have 2, 2, we have 4, 4. But 3, 3 is not there. So this relation is not reflexive. What about B? We have 1, 1 alone, 2, 2, 3, 3 and 4, 4 are not present. So we will rule out even B. When you rule out A and B, two options will go. What about C? We have 1, 1, we have 2, 2, we have 3, 3, we have 4, 4. All the elements are present, so C is included. What about 4? 1, 1, 2, 2, 3, 3, 4, 4. All the 4 elements are not present, so D is also ruled out. When we rule out D, this option will also go away. What about E? We have 1, 1, 2, 2, 3, 3 and 4, 4. So E is also included. Option number 4, C and E only will be the right answer. Only these two relations satisfy the reflexive property. Next question. Consider the following if P and Q are two statements. When we see the options A and B, what do we remember? We remember De Morgan's law. So in De Morgan's law, what we will do is we will apply the negation inside. So when we apply the negation inside, this becomes negation of P. Negation with conjunction becomes disjunction and negation of Q. Similarly, when negation is applied to disjunction, it becomes conjunction. These two laws are given exactly here. The first law, negation of P and Q is equal to negation of P or negation of Q is perfectly right. Similarly, negation of P or Q is equal to negation of P and negation of Q is also right. A and B are definitely in the answer. We can rule out 2 and 3 now. What about C? P and negation of P is equal to true. Let's take a value called 0. The negation of 0 will be 1. Will and give you 1? No. So from that itself we can mark C is wrong. Negation law states P and negation of P is equal to false. P or negation of P is equal to true. So if you take and here, the answer should be false. In order to make this true, you have to use disjunction operator. So in any way, we can rule out option 4 also. Now we will check for D. We have negation of P implies Q. When we have P implies Q, we can have negation of P or Q. When it is negation of P implies Q, we have to go with negation of negation P or Q. This part you are applying with negation. Once you apply negation, negation into negation will make this as P. Negation of disjunction will make this as conjunction and this will be negation of Q. This is the answer we are presenting here and this is what is even present in the RHS. So D is perfectly true. Now what about E? P or Q is equal to not P or not Q. Let's take P is equal to 0 and Q is equal to 0. P or Q will give you 0. Now what about negation of P? It is 1. Negation of Q it is equal to 1. What is 1 or 1? It is going to give 1. Are they equal? No. So this is wrong. From this we can mark option number 1, A, B and D only as the right answer. So if you are sure about the laws, just apply the laws. If you are not sure about the laws, just apply some value and then find it out. Next question, match list 1 with list 2. There are some queries in list 1 and the probability of those queries are given in list 2. So let's take the first one. A bag contains 6 white and 4 red balls. 2 balls are drawn at random. What is the chance they will be the same color? When you pick those 2 balls, it should be either from white or from red. Now what is the sample space here? We have 6 white balls and 4 red balls. Altogether there are 10 balls. So from these 10 balls we have to pick 2 balls. The event is 2 balls are drawn at random and they are of same color. So you will have 2 options here. One is those balls can be of white color. The other one is those balls can be of red color. Regarding sample space, out of 10 balls you have to pick 2 balls. So 10C2 is given. Regarding the event, we have to pick 2 from white, which is represented by 6C2, or we have to pick 2 from red. This will be 4C2. So it is given by 6C2 plus 4C2. This OR is actually denoted by plus. When you involve AND, it becomes multiplication. When you involve OR, it is just plus. So what is NCR? N factorial divided by R factorial and N minus R factorial. You have to apply this formula everywhere. So this is 10 factorial means 10 into 9 into 8 factorial divided by 2 factorial into 10 minus 2 is 8 factorial again. So 8 and 8 will get cancelled. 90 divided by 2 will give you 45. So n of s is equal to 45. What about n of e? We have 6c2. So this is 6 factorial divided by 2 factorial and 4 factorial plus this is 4 factorial divided by 2 factorial and 2 factorial again because 4 minus 2 is also 2. So how can you express 6 factorial? 6 into 5 into 4 factorial divided by this is 2 into 1 and this is 4 factorial as it is we can cancel plus 4 into 3 into 2 factorial divided by 2 into 1 and this is 2 factorial as it is we can cancel. Now if we cancel this will be 3 and this will be 2. 3 into 5 will give you 15 plus 2 into 3 will give you 6. So it is 21. How will you find the probability of the event here? It is n of e divided by n of s which is equal to 21 divided by 45. 7 3s are 21 and 15 3s are 45. 7 by 15 will be the probability for A. A will be mapping to 4. A4 is available in 2 options. We will rule out the other 2. Next we will get on to B. In a pack of 52 cards, one card is drawn at random. What is the probability that it is either a king or a queen? There are actually 52 cards. We will call one as ace actually. Then we have 2, 3, 4, 5, 6, 7, 8, 9, 10. For 11 it will be J, for 12 it will be Q and for 13 it will be K. Jack, Queen and King. There will be 13 cards like this and there will be 4 suits. In the sense 4 symbols will be there. So you will have heart symbol, you will have spade symbol, you will have club symbol and you will have diamond symbol. So for every symbol there will be 13 cards. So 13 plus 13 plus 13 plus 13. Altogether you will get 52 cards. Now they are saying you have to take only one card in random and that card can be a king card or a queen card. So let's take the sample space to be 52 cards. N of s is equal to 52 here. What about the event? The picked card can be a king or the picked card can be a queen. That's why we are using or here. So this is like event 1 plus event 2. Event 1 for king and event 2 for queen. How many kings are there actually? See, in heart you will have a king, in spade you will have a king, in clubs you will have a king and in diamond you will have a king. So there are 4 king possibilities out of those 52 cards. Similarly, when you take queen, there are 4 possibilities. So when you take n of event 1, it is 4 for one king from each symbol. And when you take n of e2, it is 4 for one q from each symbol. So what is the probability of the event? It is n of e1 plus n of e2 divided by n of s. What is e1's value? It is 4 plus 4 divided by 52. We will have 8 by 52. You will get 2 by 13. So 2 by 13 will be the answer for B. In the option there is something called 2 by 3. Actually it's a typo. It is actually 2 by 13. In this case we can mark B to 3. So both the options are having B3 along with A4. Since it's just a printing mistake, they have not dropped this question actually. It is wrong, but even then it is a printing mistake. So we will take this to be 2 by 13. Now let's go to C. A bag contains 6 red, 4 white and 8 blue balls. If 3 balls are drawn at random, find the probability of 1 red and 2 white balls. So let's take the sample space as 6 red, 4 white and 8 blue balls. All together how many balls are there? 6 plus 4 is 10, 10 plus 8 is 18 balls are there. Now the event is to pick 3 balls at random and they have given one should be red and the other 2 should be white. So 1 red and 2 white. They have not given like something or something. It is something and something. So in this case, we will not use plus like A and B. We have to use multiplication is what I am trying to tell you. So when they say two balls are drawn at random, you have an option to select from white and from red. So that's why A had plus here or operation. Regarding B, they asked either for a king or a queen, so again we used plus. But here the case is they want red along with 2 white. What about n of s? Out of 18 balls you have to pick 3 balls at random, so 18C3 is given. What about E? There are 6 red balls actually, so for red you have to pick 1 from 6. For white you have to pick 2 from 4. So this is what is given as 6C1, 4C2. Why are we multiplying here? It should have 1 red ball and 2 white balls. Now we have to find the value. What about 18C3? N of s is equal to 18 into 17 into 16 into 15 factorial divided by, this is 3 factorial and this is 18 minus 3 which is equal to 15 factorial. We are cancelling these two. Again we have 18 into 17 into 16 divided by 3 factorial can be expanded as 3 into 2. This can be cancelled for 3 times here. 6 3s are 18. We will have the sample space as it is. Now let's get into n of e. 6C1 will give 6 into 5 factorial divided by 1 factorial into 5 factorial into 4 factorial divided by 2 factorial. 4 minus 2 is 2 factorial. For 4 factorial we got a value of 6 I suppose. So this can be written as 4 into 3 into 2 factorial. So you can cancel these two. So we have 6 into 4 3s are 12. 12 divided by 2 will give 6 again. So this is 6 into 6 which is equal to 36. Now we have to go for probability which is equal to n of e divided by n of s which is equal to 36 divided by n of s is 3 into 17 into 16. So this will be 12. And again we have 4 3s are 12, 4 4s are 16. So this is 3 divided by 17 4s are 68. 3 by 68 is the answer. It is available in 1. So C can be mapped to 1. C1 is available in option 4. So we can rule out even option 3. Now we will go for D. A bag contains 6 red, 4 white and 8 blue balls, the same count. If 3 balls are drawn at random, find the probability of 2 blue and 1 red ball. So we will go with the same n of s. So there are totally 18 balls and so we know the n of s value will be 3 into 17 into 16 finally. We are not multiplying this, we just keep it as it is. What is the event here? 3 balls are drawn, 2 are blue and 1 is red. What about n of e? This time we have 8 blue balls. So out of 8 you have to pick 2 in case of blue and in case of red you have to pick 1 ball from 6. So it is 6C1. 6C1 is actually 6 only. So we have the values. Let's go for 8C2. 8 into 7 into 6 factorial divided by 2 factorial into 6 factorial, 8 minus 2. So 6 and 6 will get cancelled into 6 into 5 factorial. We have 1 factorial into 5 factorial. So these two will get cancelled. What about 2? This will be 4. 4 into 7 into 6 will be there as it is. Now let's calculate probability of the event. It is n of e divided by n of s which is equal to n of e is 4 into 7 into 6 divided by we have 3 into 17 into 16. This is 1 4s and this is 4 4s are. This is 3 1s are and this is 3 2s are. So 7 into 2 will give 14 divided by 17 into 4 will give 68. You can also reduce this to 7 by 34. This is also possible because this will be 2 ones are 2 and 2 twos are 4. So 17 into 2 will give 34 and this 7 around will be there. But here they have just given as 14 by 68. When you reduce 14 by 68, you will ultimately get 7 by 34. If you get either of the answer, you can mark option 2. So D will be mapping to 2. So this is also right here. Option 4 will be the right answer. Next question. A graph G with number of vertices greater and equal than 3, that is greater than or equal to 3, is a Hamiltonian graph if the degree of each vertex is greater than and equal to. So here there is a theorem called Dirac's theorem. If G is a simple graph with n vertices with n greater than or equal to 3, so here the number of vertices is what they have mentioned in the statement, such that the degree of each vertex in G is at least n by 2. Then we can say G has a Hamiltonian circuit. What do you mean by at least? At least means minimum this much should be there. So it can be equated to greater than or equal to, which is perfectly matching here. What about at most then? We can say it is less than or equal to a particular value. That's why we'll say at most 1 means not more than 1. At least 1 means 1 or more than 1. If it is saying at least n by 2, it is greater than or equal to n by 2. So n by 2 is nothing but half of the number of vertices. Option number 3 will be the right answer. Equal to means it is just n. Double number of vertices means 2 into n. 4 times the number of vertices is 4 into n. Half the number of vertices is what we can say n into 1 by 2, which is equal to n by 2. A simple path in graph that passes through every vertex exactly once is called as Hamiltonian path. A simple circuit in a graph that passes through every vertex exactly once is Hamiltonian circuit. If you take the path, we are starting from x0 and ending with xn. So we can take an example of x1, x2, x3 and x4. If you have a path from x1 to x2, x2 to x3 and x3 to x4, you can call it as Hamiltonian path. Every vertex should be visited exactly once. What about the circuit then? If you have a path from x0 to xn and again if you go back to x0, then that becomes a Hamiltonian circuit. So if you take x1, x2, x3, x4, so x1, x2 is there, x2, x3 is there, x3, x4 is there. From x4, if I am back to x1, the starting vertex. So here they are starting from x0, going till xn, again getting back to x0. So this is the start vertex. So if you are getting back to it, this is called a Hamiltonian circuit. Make sure that we are visiting every vertex exactly once. But we are getting back to the initial vertex or the source vertex once again. So this is Hamiltonian circuit. With this we are completing Unit 1 solutions.